AP Style Free Response Problem 9. Write expressions for K and Kp for the following reactions. There are 4 of them. And in the next 2 slides, we'll go through each one individually. All right, so for the first reaction, 2NH3 gas plus CO2 gas produces N2CH4O solid. So this is something to note, right? We don't include solids. And H2O gas. We don't include solids in any of our equilibrium expressions. So here's our Kc, our equilibrium constant based on concentration. Will be the concentration of the water over the concentration of the NH3 raised to the second power, because we have this coefficient, right? Times the concentration of CO2. And the Kp expression, because these are all gases, is similar. The only difference is that instead of square brackets for concentration, we just use parentheses and then P for pressure. The second reaction, we have 2 gases and 1 solid. So again, we don't include solids or liquids in any of our equilibrium expressions. So our Kc will just be the concentration of N2 times the concentration of Br2, and then of course it should be cubed because of our coefficient 3. And these are both gases. So similarly, our Kp expression will look the same, but instead of square brackets for concentration, we use parentheses and then a P for the pressure. Part C, we have 2 solids, so of course we won't include those in any equilibrium expression, and 1 gas. So we get K is equal to the concentration of O2 cubed. The cubed comes from our coefficient 3. And because it's a gas, Kp will look similar, but instead of square brackets for concentration, we'll use parentheses and we'll say P for pressure. And finally, part D, we have a solid and a liquid. And otherwise, we have 2 gases, one on the left, one on the right. So our K will just be the concentration of H2O, the product, over the concentration of the reactant H2. And again, they're both gases, so our Kp expression is similar, but instead of square brackets, we use parentheses. And then we use P to show that these are the partial pressures of the H2O gas and the H2 gas.